Anti-lock brakes are a popular feature found on more and more vehicles every year. This month on VideoTec, we'll look at the simple but effective anti-lock braking system found on Eagle Talon and on Summit Wagon models. Anytime the braking force exceeds the amount of traction that the wheel-tire combination can provide with the road, wheels can begin to display a locking tendency. And of course, should the front wheels lose their grip on the road, the driver could have a difficult time steering the vehicle. There are several factors that determine at what point a wheel will begin to lose traction when braking. These include the type of road surface, condition of the vehicle's tires, and the condition of its brakes. Slippery road surfaces like loose gravel, water, or ice provide little traction for any tire. So on these surfaces, a wheel locking tendency is more likely to occur. The benefit in adding ABS to a vehicle is that it can prevent wheels from exhibiting this locking tendency under these types of conditions. Controlling the locking tendency allows the driver to slow down as quickly as possible and still maintain steering control. The result is safe, more predictable handling. Let's take a closer look at how the anti-lock brake system accomplishes this. The anti-lock braking system on Talon and Summit Wagon is similar to other four-wheel anti-lock systems in that it uses sensors mounted at each wheel, working with a toothed tone wheel to generate electrical pulses that are used to represent wheel speed. These pulses are sent to an electronic control unit, or ECU, which compares this data, along with that provided by other braking system sensors, to patterns of normal vehicle braking, which are programmed into the ECU. Should the information provided to the ECU suggest that a wheel is exhibiting a locking tendency, the ECU moves the valve controlling hydraulic fluid for that wheel to the hold position. At this point, the hydraulic pressure provided to that wheel circuit is held constant. Should the wheel still exhibit a locking tendency, the ECU directs the same valve to the pressure reduction mode, relieving the braking pressure in that circuit and allowing the wheel to rotate. As the wheel starts to move again, the ECU determines whether it is best to continue reducing pressure, hold pressure, or allow pressure in the wheel circuit to increase. Of course, this all happens in a fraction of a second while the driver has the brake pedal firmly depressed. The result of all this is that fluid pressure to a vehicle's brakes is modulated much faster and more efficiently than possible with the driver's foot. In fact, manual pumping of the brakes by the driver is not recommended on vehicles with ABS. Instead, the driver should apply firm and constant pressure to the brake pedal. During those braking situations where the ABS is called into operation, the driver will notice a pulsing of the brake pedal. This is a normal operating characteristic and is the result of the ABS pump motor working to return brake fluid to the master cylinder reservoir. In non-ABS braking situations, the pedal feel will be the same as that on a vehicle with conventional brakes. Should a component in the system fail, the ECU will prevent the flow of electrical current to the valves in the hydraulic unit. The braking system will then operate as in a non-ABS equipped vehicle. This is referred to as the fail-safe mode. Should this happen, the ABS warning light on the instrument panel will remain illuminated to bring this condition to the driver's attention. When an ABS-equipped vehicle is started and reaches a speed of approximately 4 miles per hour, the system performs a self-check of its valves and wheel speed sensors. A whining sound may sometimes be heard as the ABS pump motor runs momentarily. This self-check is a routine occurrence and presents no problem for a vehicle that is operating properly. On vehicles that are being jump-started because of a discharged battery, however, the power requirements of the self-check may cause the engine to misfire and make driving impossible. To avoid this, the electronics for the anti-lock brake system should be disabled prior to starting a vehicle with a discharged battery. The proper procedure for this is covered in the owner's manual and is described in Group 5 of the service manual under the heading Flat Battery Remedy. On Talon models, disconnect the ABS wiring harness located near the system's hydraulic unit. The ABS warning light will illuminate once the vehicle is started. For Summit Wagon models, the fusible link for the anti-lock brake system should be removed. It is located in the engine compartment near the positive terminal of the vehicle's battery. Again, the ABS warning light will remain on after the vehicle is started. In both cases, the system should be reconnected once the battery is sufficiently charged. Then, restart the engine and check that the ABS warning light is no longer illuminated. One feature of this anti-lock system is that it operates without the use of a high-pressure accumulator. This means that there is no need to relieve fluid pressure in the system prior to service. Let's take a closer look at the components that make up the anti-lock braking system. As I mentioned earlier, the wheel speed sensor works with the tone wheel to create an AC voltage signal which is read by the ECU. The signal is generated through the process of magnetic induction as the teeth of the tone wheel pass the sensor. A properly functioning sensor will produce a consistent wave pattern when viewed on an oscilloscope. The condition of the tone wheel and the correct positioning of the sensor unit are vital to proper operation of the system. Each of the vehicle's tone wheels should have 47 teeth. Should any of the teeth be chipped or missing, an irregular signal will be generated by the wheel speed sensor. Examine the tip of the sensor's pole piece for foreign material or damage that could affect signal quality. Use a blade-type feeler gauge to check the gap between the speed sensor and the tone wheel. A brass gauge works best as it is not affected by the magnet in the sensor. The brake section of your service manual lists the correct air gap range. Note that these recommendations can vary depending on how the vehicle is equipped. The brackets used for mounting the speed sensors are not interchangeable. They are labeled to indicate their location on the vehicle. Be sure that the speed sensor cable is secure and not twisted, as this can damage the lead and result in poor signal quality. The electronic control unit, or ECU, serves as the brain of the anti-lock brake system. It is located behind the rear quarter trim panel on Talon models and in the center console on Summit Wagon. The ECU receives its operating power through an ABS relay when the ignition key is moved to the on position. On Talon models, this relay is located on the bracket attached to the ECU. On Summit Wagon, the ABS relay is attached to the dash panel. When powered up, the ECU receives inputs from the wheel speed sensors and the stop lamp switch. On all-wheel drive models, an additional G sensor input is included. ECU outputs include the signals sent to the solenoid valves in the hydraulic unit, ABS warning light, valve and pump motor relays, and a DRV2 diagnostic connector. This is how it all looks in schematic form. Should the ECU input suggest that a wheel is displaying a locking tendency, the ECU provides a ground to complete the circuit for the appropriate solenoid valve in the hydraulic unit, and, if required, the ABS pump motor relay. The stop lamp switch that actuates the vehicle's brake lights also serves as an important ECU input. It is mounted on a bracket just above the brake pedal on all vehicles. The ECU will not operate any of the ABS functions until it receives an indication that the brake pedal has been depressed. So, a failure of this switch will prevent the ABS from operating. And furthermore, the ABS warning light will not indicate this situation to the driver. Fortunately, vehicles with stop lamp switch failures are usually brought in for service immediately when the driver finds that his brake lights are not operating. Less obvious would be a failure of the G sensor, which is found only on all-wheel drive models. These vehicles require an additional input because when braking on a slippery surface, all four wheels tend to decelerate at close to the same rate. This is due in part to the fact that they are linked by a propeller shaft. If the wheel speed sensors indicate that the wheels have stopped turning, the ECU might be led to believe that the vehicle has come to a stop. The G sensor indicates vehicle deceleration. When the ECU compares the deceleration figures provided by the wheel speed sensors with the information provided by the G sensor, it realizes that the vehicle is sliding on a low-friction surface and chooses the appropriate anti-lock response. The G sensor on Talon is mounted on a bracket between the rear seatbelt latches. On Summit Wagon models, the G-sensor is found in the center console. There is a simple way of determining if a G-sensor is operating properly. Use an ohm meter to measure resistance between the two terminals with the unit on a level surface. Slowly incline the G-sensor in the direction of forward vehicle travel. There should be infinite resistance once the sensor has reached an angle of about 30 degrees. The same thing should happen when tilting the unit in the opposite direction. If you were to think of the ECU as the brain of the anti-lock brake system, then the hydraulic unit would serve as its heart. This is where those valves that actually regulate pressure to the brakes are located. As you've seen, on front-wheel drive models, there are 3 valves in the unit, one for each front wheel and a single valve for the rear wheels. All-wheel drive models use only 2 valves, each controlling one of the front wheels and both rear wheels. We'll look at how this is accomplished a little later. With both systems, the positioning of these valves determines the amount of brake fluid pressure that will be delivered to the wheels. Let's take a closer look at how these valves operate. There are 3 positions that each of these valves in the hydraulic unit can take. The first is the position that the valve assumes when ABS is not operating. As the brake pedal is applied, hydraulic pressure is allowed to build in the circuit. A check ball prevents fluid from escaping to the ABS pump motor reservoir. There is no current flowing to the solenoid valve at this time. When the ECU senses a wheel locking tendency, it sends a 2-amp current to the solenoid controlling the valve for that wheel. The solenoid forces the spring-loaded check ball to move into position, preventing additional fluid from the master cylinder from entering the wheel circuit. Hydraulic pressure at the wheel is held constant. This is what was referred to earlier as the hold position. Should the ECU determine that the locking tendency has not been reduced, it sends a 5-amp current to the solenoid controlling the valve for that wheel. As in the hold position, a check ball is in position to prevent fluid from the master cylinder from entering the valve. But in this pressure reduction mode, the check ball at the other end of the valve opens, allowing the fluid to flow from the wheel circuit to the pump reservoir. This relieves the pressure that had built up in the wheel circuit. When the valve is moved to the pressure reduction mode, the ABS pump motor operates to return the fluid from the pump reservoir to the master cylinder reservoir. The action of the pump motor is what causes the pulsing that is felt in the brake pedal during ABS operation. Here is a view of the electrical circuit that operates the solenoid valves on front-wheel drive models. Note that the ECU is the source of both power and ground for the relays, and the ground that determines which solenoid valve will function. The circuit for all-wheel drive models is similar, it just incorporates one less solenoid valve and adds a G-sensor input. Perhaps you're wondering how one solenoid valve can control pressure to both rear wheels when these vehicles have a dual diagonal braking system. The solution is the addition of a valving mechanism that can balance braking pressure between the 2 rear wheels, while allowing their fluid sources to remain separate. On front-wheel drive models, this is accomplished through the use of a plunger valve. The plunger valve is contained in the hydraulic unit, and through the use of a balance piston, equalizes the braking pressure available at both rear wheels. When the rear wheel solenoid valve is not being operated by the anti-lock braking system, the balance piston is pushed as far as possible to the left by spring pressure. The result is equal braking pressure in each of the valve's fluid chambers. When the solenoid valve reduces pressure, as a locking tendency is detected in one of the rear wheels, the balance piston is pushed to the right by the force of the brake fluid from the master cylinder. As this happens, the cutoff valve is closed and fluid pressure to the brake circuit is decreased. Both rear wheels experience a reduction in pressure. The right rear wheel due to the direct action of the ABS solenoid valve, the left rear wheel due to the action of the plunger valve. At no time do they share brake fluid. Should there be a loss of fluid in one of the lines, the other will still function. However, ABS will not operate. On all-wheel drive models, a select low valve, or SLV, is used. It is similar to the plunger valve in that it also equalizes pressure to the rear brakes through the use of a piston-type mechanism. But unlike the plunger valve, pressure to both rear wheels is reduced whenever pressure to either of the front wheels is relieved. This is important on all-wheel drive models where front and rear axles are connected by a propeller shaft. As with the plunger valve system, the SLV maintains the dual diagonal braking capability of the vehicle, so at no time is fluid from the two circuits shared. And, like the plunger valve, the SLV is built into the hydraulic unit. The hydraulic unit on Eagle Talon models is located on the passenger's side of the engine compartment. On Summit Wagon models, the hydraulic unit can be found at the front of the engine compartment on the driver's side. The hydraulic unit is a non-serviceable component. Should you be required to remove or replace it, do so with care, as it is surprisingly heavy. Do not lay the unit on its side or subject it to any type of impacts, as this can cause damage to the internal valve mechanisms. A warning light is included on the instrument panel of all ABS-equipped vehicles. When the ignition key is cycled to the on position, this light will briefly illuminate and flash. It will do the same when the key is moved to the start position. At both of these times, a self-check of the ECU's electrical circuits is made. On front-wheel drive models, the ABS light will illuminate and then quickly flash once at both the on and start positions. On all-wheel drive models, it will illuminate and then quickly flash 3 times at the same ignition key positions. Any other operation of this light indicates a fault within the system. We'll look at some of the possibilities in the next segment. The ABS warning light can be used to help diagnose the electrical circuits in the anti-lock brake system. A light that fails to illuminate at any key position indicates a burned-out bulb or an open in the ABS warning light circuit. The fuse that provides power for the circuit is a good place to start your search if the other warning lamps on the instrument panel also fail to illuminate. An ABS warning light that remains on steadily with the key in the on position could indicate several problems. The ECU could be malfunctioning, or it may have put the system into the fail-safe mode due to the failure of one or more of the ABS components. It's also possible that there could be a short in the warning light circuit. A light that flashes but does not illuminate when the key is cycled to the start position could indicate a malfunction of the valve relay. There might also be a break in one of the wiring harnesses serving this circuit. Finally, should the light illuminate as the key is cycled to each position but fail to flash, the problem could be a damaged ECU or an open in the warning light circuit. Your service manual includes a list of these conditions and flowcharts for completing the diagnosis. When using the service manuals, note that there are separate sections for front and all-wheel drive models. Don't make the mistake of using the all-wheel drive section to diagnose a front-wheel drive vehicle, or vice versa. Fault codes for the various system components are stored in the memory of the ECU and can be retrieved using the DRB2, which is referred to in the service manuals as the multi-use tester, or MUT. A chart containing the fault codes for both front and all-wheel drive vehicles is included in the reference guide that accompanies this video. Note the addition of a fault code for the G sensor on all-wheel drive models. Be aware that the 1991 DRB2 cartridge reversed the fault codes for the front wheel speed sensors. Should the DRB2 indicate a problem with the right front sensor, the left front sensor should actually be investigated. The 9291 cartridge provides the correct diagnosis and should be used when working on 1991 Talons with ABS. Special care needs to be taken when using the DRB2 to read fault codes on these vehicles. The DRB2 should be plugged in with the ignition off, then turn the ignition key to the on position and select the appropriate model and screens. On some vehicles, it may take several minutes for the DRB2 to complete communication with the vehicle's diagnostic system. Once you have completed using the DRB2, be sure to turn off the ignition before disconnecting the DRB2 from the diagnostic connector. Otherwise, fault code 55 for the ECU will be stored in the memory of the vehicle's ABS control unit. This could lead to an improper diagnosis of a vehicle at a later date. If you read a fault code 55 on one of these vehicles, erase the code and test the system for proper system operation before servicing or replacing the ECU. This Summit wagon was brought in for service because its ABS warning light remains on. After verifying the complaint, use the DRB2 to look for any fault codes that may be present. Be sure to connect the DRB2 with the ignition in the off position. Record any fault codes that may appear. In this case, code 51 indicates a problem with the valve relay. Erase the fault code and then remove the DRB2. Be sure that the ignition is off or you will store an error code in the ECU's memory. The 1991 Powertrain Diagnostic Procedures Manual with the ABS supplement can be used for both 1991 and 92 models. In this case, it will refer you to Chart E6 in the ABS troubleshooting section of the service manual. This chart contains a schematic of the ABS warning light drive circuit and a diagnostic flow chart. The first step is to remove and check the valve relay. Use a screwdriver to release the tabs securing the relay cover to the hydraulic unit. Then remove the smaller of the two relays. This is the valve relay. Use an ohmmeter to test the relay, referring to the chart found in the hydraulic unit section of the service manual. The resistance between terminals 85 and 86 should be between 60 and 120 ohms. This relay has an open circuit, which prevents it from operating properly. This break in the relay coil forces the valve relay to stay in the open position. The system is in the fail-safe mode, and the ABS warning light is supplied with a ground. That explains why the light was staying on. Now that the failed component has been identified, install a new relay and return the plastic cover to its original position. Then road test the vehicle for proper ABS operation. That does it for this month's VideoTec. Now that you're more familiar with this anti-lock brake system, you'll find that most of the service it requires is really pretty simple. With the information we've just covered and the material provided in your service manuals, you'll be ready to tackle those ABS problems with confidence. For more information on braking systems, consult the catalog for courses provided by the Chrysler Training Center in your area. We'll see you next month on VideoTec.